We will discuss types of order of reaction. That is, first one is zero order reaction. Zero order reaction. What is zero order reaction, sir? The rate of reaction is directly proportional to zero power of the concentration. For example, A gives rise to product R is equal to K into concentration of A power 0. The sum of the powers of the concentration terms of the reactant is equal to 0 is called zero order reaction. The decomposition of gases on solid surfaces. What are the examples here? Example for decomposition reactions. The decomposition of gases on solid surface. Follows first order at low temperature, at very low and high pressure. At low temperature and low pressure. For example, here decomposition of ammonia. In the presence of iron catalyst to form ammonia N2O3H2. Decomposition of ammonia in the presence of molybdenum act as a catalyst HN. And another reaction when hydrogen combines with chlorine to form hydrogen chloride in the presence of sunlight. Or decomposition of Hi in the presence of sunlight to H2 plus I2. It is also example for zero order reaction. Simply, the rate of reaction is directly proportional to the zero power of concentration of the reactants. I hope it is clear. The reaction whose rate does not depend upon the concentration and time is known as a zero order reaction. One more important point here. The reaction whose rate does not depend on concentration of reactants and time is called zero order reaction. Simply, for zero order reaction, the rate of reaction is independent of the concentration of reactant. Integrated rate equation for zero order reaction. You can observe here A gives rise to product. At initial time, the concentration of A or concentration of A naught product is zero. After T time, the concentration of reactant can be reduced or simply concentration of A. Here's some X. Here R is equal to the K into a concentration of A power 0. The rate of reaction is equal to the rate of reaction is directly proportional to the 0 power of concentration of reactant is called integrated rate equation of 0 order. You know order formula minus dA by dt is equal to K anything power 0 1 only. Now minus dA is equal to K into dt. Applying integration on both sides. Applying integration on both sides. Okay, that means here minus integral of minus d concentration of A is equal to K into integral dt. Okay, integration definition both are opposite to each other. That's why concentration of A is equal to K into T. After completion of integration, one constant term is added. That is called integration constant I. Already you know at initial time the concentration of A is nothing but concentration of A naught and T is equal to 0. The two terms substitute in the equation 1. We will get minus A naught is equal to I. This is equation 2. This equation 2 is substituted with equation 1. Minus A is equal to K into T plus of minus concentration of A naught. This term transposing that side. Concentration of A naught minus concentration of A is equal to KT. T transposing that side. Concentration of A naught minus concentration of A by T is equal to K. This is the integrated rate equation for zero order reaction. For zero order reaction. In case if you take initial concentration here, small a, after some time minus a minus x by t is equal to, here k is equal to this one, k is equal to minus a plus a cancel, x by t is also one more formula. K is equal to x by t is the formula of integrated rate equation for zero order reaction. I hope for zero order reaction the rate of reaction independent of the concentration of reactant. Some graphical representations are there. Graphs, some graphical representation of zero order reaction. You know, K is equal to concentration of A naught minus concentration of A by T is the formula. T transposing that side, concentration of A naught minus concentration. It is comparing with straight line. Y is equal to mx plus c, where c is equal to 0, m is equal to k, slope k. The plot versus time versus on time in x-axis, change of concentration A naught minus A on y-axis. Intercept c means the straight line is passing through origin. Slope m is equal to k. This is the first graph. Second graph, Same this equation. Kt is equal to concentration of A naught minus concentration of A minus concentration of A transposing that side. It is comparing with the straight line equation. Y is equal to mx plus c, where c is equal to concentration of A, m is equal to k. The plot versus time versus concentration of A naught, straight line passing through the not pass straight line. This is slope m is equal to k. This is called concentration of A. In the same way, one more graph is there. Kt here, this one transposing that side is equal to minus A, multiplying minus on both sides, minus Kt plus concentration of A naught is equal to concentration of A. It is comparing with straight line equation. Y is equal to mx plus c, where c is equal to concentration of A naught, m is equal to minus k. Negative slope here. X-axis, y-axis. In x-axis in time. Now I am taking in y-axis concentration of A. Concentration of A. The slope is negative with the straight line. That m is equal to minus k. This is called intercept concentration of A naught. So these are the graphical representations of zero order reactions. And one more method, half-life method. Half-life period of reaction, especially half-life period of first order reaction. Now I am taking here half-life period of first order. K is equal to concentration of A naught minus concentration of A by T. What is the half-life period, sir? The time in which the concentration of reactant can be reduced to 1/2 of its initial concentration of reactant is called half-life period. The half-life period of a reaction is the time in which the concentration of the reactant, the concentration of reactants can be reduced to 1/2, of its initial concentration. Of reactant. It is represented by the symbol either T half or T50%. T half or T50%. Now you can observe here K is equal to A naught is nothing but, now I am taking here concentration of A. Initial concentration A naught by 2. And T is equal to T half. Replacing these terms in the equation 1, we will get here K is equal to A naught minus A naught by 2 by T. Then K is equal to 2 concentration of A naught minus concentration of A naught by T. Means concentration of A naught by T. By 2 also is there here. Or if you take one more expression, x by t is there. If x is nothing but small a by 2, t is nothing but t half. K is equal to a by 2 by t half. Instead of t, if you take t half here, t half is equal to concentration of A naught by 2K is the formula. Here also same, T half is equal to A by 2K. The half-life reaction of zero order reactions depends on the initial concentration of reactant. It depends on the initial concentration of reactant. In this half-life reaction, also some graphical representations are there.